We live on a planet ruled by rhythms. Some are obvious, like day and night. Others, like El Nino and La Nina, are hidden within the vast oceans. These climate patterns can wreak havoc on our weather, causing floods, droughts, and more. Predicting them has always been a challenge, until now. Enter BCNN, a revolutionary technology developed by the Indian National Centre for Ocean Information Services, INCOIS. BCNN is like having a sixth sense, allowing us to hear the whispers of the ocean and predict its next move. This is not magic, it's science, powered by the incredible abilities of artificial intelligence. BCNN is at the forefront of a technological revolution: artificial intelligence. AI is about teaching machines to learn and make decisions like humans do. Think of it like this. Instead of explicitly programming a computer with every single rule, we feed it data and let it figure out the rules itself. BCNN utilizes a specific type of AI called machine learning. In this case, it's deep learning. Deep learning uses artificial neural networks, which are inspired by the human brain. Like our brains learn from experience, these networks learn from data. The more data they process, the smarter they become at identifying patterns and making predictions. BCNN's deep learning algorithms sift through mountains of oceanic data, identifying subtle correlations and patterns that traditional methods miss. This is the key to its remarkable predictive power. The heart of BCNN is its neural network. Imagine a network of interconnected neurons, each responsible for processing a small piece of information. As data flows through this network, each neuron performs a simple calculation and passes the result to its neighbors. This process repeats across layers, with each layer learning increasingly complex features from the data. In BCNN, the initial layers might detect basic patterns like sea surface temperature variations. Deeper layers then combine these patterns to identify larger-scale phenomena like the formation of El Nino or La Nina. The network's final output is a prediction, for example, the likelihood of an El Nino event occurring in the next year. This sophisticated architecture allows BCNN to make sense of complex, interconnected factors that influence our climate. Data is the lifeblood of BCNN. Just like we need food to survive, BCNN needs data to learn and make predictions. It thrives on a constant diet of information about the ocean. But not just any information. It needs specific data like sea surface temperatures, wind speeds, and ocean currents. This data is collected by a global network of satellites, buoys, and ships. Imagine these instruments as the eyes and ears of BCNN, constantly monitoring the pulse of our oceans. The more data we feed BCNN, the more accurate its predictions become. It's like giving a detective more clues to solve a case. This constant flow of information allows BCNN to adapt to the ever-changing dynamics of our planet's climate system. El Nino and La Nina are prime examples of how BCNN is changing the game. These climate patterns, characterized by unusual warming, El Nino, or cooling, La Nina, of surface waters in the Pacific Ocean, can have global consequences. They can trigger extreme weather events like floods, droughts, and heat waves, impacting agriculture, fisheries, and human lives. Predicting these events accurately and with sufficient lead time is crucial for mitigating their impacts. BCNN excels in this area. Traditional methods could only predict El Nino or La Nina a few months in advance. BCNN, on the other hand, can provide accurate predictions up to 15 months ahead. This extended lead time gives us a critical window of opportunity to prepare and adapt. BCNN is not just a scientific marvel, it's a powerful tool with real-world applications. Its ability to predict climate phenomena like El Nino and La Nina with unprecedented accuracy, has far-reaching implications for disaster management, agriculture, and fisheries. For disaster management agencies, BCNN's predictions are invaluable. Knowing that an El Niño-induced drought is likely to occur allows governments to take proactive measures, such as securing water resources, implementing drought-resistant farming techniques, and preparing for potential wildfires. In agriculture, BCNN's forecasts can help farmers make informed decisions about what crops to plant, when to irrigate, and when to harvest, maximizing yields and minimizing losses. Similarly, in fisheries, understanding the impact of El Niño or La Nina on fish populations allows for sustainable fishing practices and the protection of marine ecosystems. BCNN represents a paradigm shift in our ability to understand and predict the complexities of our planet's climate system. Its ability to learn from vast amounts of data, identify subtle patterns, and make accurate predictions with extended lead times opens up a new era of climate prediction. As technology advances and our understanding of climate science deepens, BCNN's capabilities will only continue to grow. We can envision a future where BCNN's predictions become even more accurate and granular, providing us with localized climate information tailored to specific regions and sectors. Imagine receiving personalized climate forecasts for your farm, your city, or even your neighborhood, allowing for hyperlocal adaptation and mitigation strategies. BCNN is not just about predicting the weather, it's about empowering us to make informed decisions that safeguard our planet and secure a sustainable future for generations to come.